Welcome to Elemental Fun, a historical and cultural look of the elements of the periodic table. My name is Grace.
And I'm Cindy.
And today we're going to be talking about two elements. We're going to be talking about sodium and chlorine.
And don't mind my voice, I am still a little sick.
If you hear some howling in the background, that is the high winds and the wind advisory we have.
Oh, gale warning.
Yeah.
Especially for Whidbey.
Hold on tight.
Don't let your salt get blown away.
Right.
That's so
but
funny.
First, a few updates.
Updates. These are updates I don't know.
I know. I'm really excited to tell you about them. One is I found a new use for carbon.
Ooh.
Yes, it is called air ink.
Air ink?
Yes. So scientists, brilliant people, are taking the exhaust pollution from cars, and they are extracting the carbon out of the soot and are creating high quality ink with it.
Really?
Uh-huh.
How do they do that?
I don't know, but they do extract they take out all the toxins and all the stuff that basically gives you cancer, and it's left with carbon, and they make a really nice ink with it. And you can buy pens with it, and you can also buy it as a paint, I think.
Air ink.
Yeah.
Cool. I'll have to look for that.
I was really excited to
that's
hear
really
about
neat.
that.
Cool scientists.
Yeah, I know. Way to go, artists/scientists/innovators. I think I just said innovators. Innovators.
Inventors.
Also, I have a second update.
Number two.
So, a while back I made a joke about geologists. I don't know if you remember it. When I said, why are geologists always single? Because they date rocks.
Oh.
Well, I told this fabulous joke to my dad, who has a very dry sense of humor. And he told it in an email to my Uncle Ross, who is a geologist.
Oh.
And
Didn't see this going not well.
And he replied back with one line. He says, "It has been a sedimentary life."
So this is where I go, knee slapper. It's good. Sedimentary. Oh.
Shout out to Uncle Ross.
I love bad chemistry jokes.
I love any puns.
Puns are great.
I'm gonna get that shirt that has like my chemical jokes are all boring or something like that.
Oh, well, there's one that's, I told a joke, it got no reaction. I told a chemistry joke, it got no reaction. Wah, wah, wah. That's a good
make
one.
shirts with those on them. I might have to buy one.
I would think.
Or at least a copy mug.
I do have a chemistry, one of my favorite chemistry jokes, and I have a t-shirt of it. Or I used to, and I can't find it anymore. But it says, if you're not part of the solution, you're part of the precipitate. Because in a solution, the thing that comes out of the solution is a precipitate, the problem. Yeah, it's my favorite one.
That's pretty funny. I like it. Yeah.
I wish I could find the t-shirt.
I have a t-shirt that has the chemical compound for caffeine on it.
Oh yeah, those are good.
Yeah, but it says something kind of inappropriate on the front of it, so I can't wear it.
Probably shouldn't wear it to
as
school.
A teacher.
No,
but that's okay. And I think it's too small for me anyway. So I think
but that's also probably not good to wear to school. Just want to put that out there.
I agree. Okay, so those are my two very short updates.
I like them.
There might occasionally be updates when we finally actually get listeners that respond. Those can also be in the updates. I hope
if you have something to say,
please tell us if we say anything wrong or when we say anything wrong, or if you enjoy it, or just we'll fan
shout
mail.
out, say hi.
Do some updates and whatnot. If we get something wrong, I'd love to be told, but in a nice way.
I am the first person. I am a scientist, and the more you know, the more you know you don't know, and there are plenty of things I don't know.
There's a crap ton of stuff I don't know.
So please correct me.
All right, let's dive right in. Well,
On to sodium.
it's interesting. Yeah, we're going to start with sodium, and we're going to go into chlorine, and then I'm going to go a little bit. Grace, this is Grace, by the way. I'm going to go into.
They can tell it's not nasal voice.
Oh, that's true.
This one.
This
please.
episode. To the history, the cultural history of the two chemicals together, which make yummy, delicious salt.
Salt.
So,
Crazy.
go ahead and start us into
All
sodium.
right. Well, we will begin at the beginning. Well, actually, if you want to go all the way, sodium is actually produced in heavy stars when atoms of neon gain a proton. And that neon was created by carbon atoms fusing together in fusion reactions.
That is from the very beginning.
This is what I just thought I'd just start, you know?
So this is the difference between Cindy and myself. Like, I'm like, the beginning. It's in the earth, and it's been there forever. And Cindy's like, no. Let's go back to...
It's created in the stars.
Let's go back to the Big Bang. That's the beginning. I'm like, oh, it's not just like, there was the earth.
And there was stuff.
Yeah.
It was, or when I was going to go with when it was discovered. Then I was like, well, no, actually.
Is it discovered?
back.
Wait.
It was discovered.
How was it discovered?
Oh, I'm glad you asked.
Yeah.
There's a...
Because it's not really found in its...
Correct. So people have known about sodium and chloride and particularly the two together for a very, very long time.
That is kind of the most common form in which those two chemicals are found.
Right.
Is
It's
salt.
Right. It's you can salt flats. You can go see those, oceans of salt, which we'll talk about a little bit later. But they didn't know it was a separate, they're in two individual elements, for a long time.
When did they find out?
In 1807.
1807.
And funnily enough, Sir Humphrey Davy. Sorry.
Humphrey Davy.
Humphrey Davy.
I like it.
Sir. Actually found...
Didn't he find both?
He discovered both, yes. Now, well, kind of, chlorine's a little bit trickier.
Yeah.
But he was the first to isolate them.
Oh.
Right. So in 1807... he had sodium hydroxide, which is Na and an oxygen and a hydrogen.
Okay.
It's also called lye.
Okay.
To make soap
Yeah,
out of,
lye.
right?
Okay.
Very, very basic. And by basic, I mean not simple. I mean basic in the acid-basic scale. It is...
the opposite of acidic.
right,
basic,
not just
simple.
simple basic.
Okay.
Right, sodium hydroxide is a 14 on the 0 to 14 scale of...
That's
of
green, right? No, purple. What's the color? No, green's...
Depends on the... Sometimes it can depend on the scale you're using.
That's true.
I think it's green.
That was my absolutely favorite. That was my favorite part of chemistry is when you would test,
oh, yeah.
An acid or a base and you'd get that color scale and you'd see, I think maybe green's actually more neutral and then it's like purple and blue. Then like red I think is, I think Cindy's going to look it up.
I was going to pull it up because, hey, we have the internet.
It was just so neat. I remember, and I actually did like science experiments where I would, add an acid to something to change the pH of it, the pH scale.
So green is neutral.
Yeah,
and
green
then
is
red
neutral.
is acidic and blue, purple basically is basic.
It's basic.
Yes.
Cool.
So you can think of sodium hydroxide as
And you
purple.
can actually change the color of your hydrangeas
This is right.
by changing the acidity
Of the soil.
So if you want pink hydrangeas,
Make it acidic.
you have to add more acid to your soil.
Now, I would suggest do not actually pour acid
pour
onto your hydrangeas. You will add some kind of... some kind of like thing.
I see someone like just
food.
pouring acid.
She told me to pour acid on the
Just watching
hydrangea.
as the poor hydrangea bush is just like dissolving. They're like, I don't understand.
That's what she told me to do.
Elemental Fun told us to pour acid onto our flowers.
You will add some kind of chemical that is a slightly more acidic.
Coffee
Coffee will make it
That's a very
acidic.
simple.
Excellent one. On the other end, if you want them more bluish, then you put it in something more basic on it.
Which you could ask any plant store.
We'll tell you, don't put lye on your hydrangeas.
I don't get it. I poured lye straight
Totally
on the plant.
fine.
It died.
Now, so what happens when you have something that's really acidic? Like what happens if you get it on you? What happens?
It burns?
Right, it burns. What happens if you get something basic on you?
Oh, wait, I know this. I don't know it.
It burns.
I was gonna say, does it burn?
It burns. So we always think of things that are acidic as that, oh, that's bad. Don't put that on your skin. Mm-hmm. But nobody really thinks about things that are basic. Mm-hmm. And because a lot of your cleaning solutions are all basic. So, you're cleaning with it and things like that. But something that's really basic will do the exact same thing to you as something that's really acidic.
Right.
So I had a side story. This is going to be a long episode.
We thought it was going to be short.
This is not gonna
we were so wrong.
So I lived in Florida, and we have hurricanes. And when we have hurricanes...
Wait. There's hurricanes in Florida?
Yeah.
Oh.
Yeah. In case you didn't know.
I'm born and raised in Washington State. I'm like, what's a hurricane?
Hurricane's a really big storm.
Isn't it just a twirly cloud?
I wish it was. Yeah, it's beautiful from space. Not so much on the land.
Okay, anyways.
Right. So, there's hurricanes. So when you have hurricanes, oftentimes we lose power. We lose power for a week, right? So I had friends, and she was out of town during the hurricane. Her husband was there. He did not take the food out of the fridge. So you can imagine what happened in a week.
Nasty.
Mm-hmm. So his wife came back, and she had to clean it. And she used straight up bleach without ventilation.
Oh.
So she had like 2nd-degree burns like in her throat because of the base. Because you people don't think about that bases are as bad as acids, but they are.
Well, I just think of bleach as like, hi, don't breathe bleach.
Yeah. She was just cleaning. Yeah, it wasn't good. So don't use full-on bleach without good ventilation.
Yeah.
Side story.
I have a feeling we might get sued by the end of this episode. We're like putting bad ideas.
We should put a disclaimer at the beginning of this one. Disclaimer:
Don't
do
take
not
any of our advice without seeking advice of a professional.
We're telling you things not to do, not things to do.
Yes.
That's okay.
Pretty sure we haven't told you to do anything.
No.
Don't mishear us, please.
Okay, so this sodium hydroxide.
Right, sorry.
So he isolated it through electrolysis of sodium hydroxide.
So how in 1807 did he do that? Do you know?
That was, if you heard that was my dog in the background hacking up a treat that she just ate. I apologize for that.
That wasn't Cindy going,
That was not me. I don't know.
I'm just curious. I don't think you need to have the answer, but
I'm not sure. Well, I mean, it is electricity. When did we get? I think we had something there. Yeah. I'm really not good with history. Yeah, I'm not sure. Yeah, I didn't look at it.
If you know, because you know the history of electricity, please email us. I would love to know, because I'm always baffled about the people who discover these elements, like how they even thought to separate things back then. I look at a rock and I'm like, that's a rock. Like, I don't think
that's got stuff in it.
I bet there's different. That we could break this down into more simplistic elements. I'm just like, that's a rock.
It's good times. It's got stuff in it.
Is there?
And what's interesting is the name came. So early on, they had no distinction between potassium and sodium because, as we'll find, potassium and sodium both really like chlorine and are found a lot in nature. Right. Okay. So they didn't, they kind of thought that that was just the thing, and that it wasn't separate compounds. So the name comes from the English word soda, and sodium hydroxide was known as caustic soda before they knew what it was made up of.
Okay.
So they called it caustic soda, and also the name for.
Sorry.
My dog is ridiculous. The Latin name for sodium, because the symbol for sodium is Na, comes from the Latin natrium, and in Germany, sodium hydroxide is Natronlauge, something like that. And this guy named Gilbert liked natronium, so this other guy liked natrium, and so that became natrium. That's why the symbol is Na versus like SO or something like
Latin.
that. Mm-hmm. Which many of the symbols are.
Many of them are, which no one explained that to me when I took chemistry in high school. And I was just like, why do they all have different names? I don't understand.
Some of them make sense, and some of it, like potassium, is a K. All right.
We'll figure out why.
Potassium.
In a few episodes.
So what's cool also is, it's a metal. They call it an alkali metal. But it's sodium in nature is by itself is a soft, lustrous metal. Mm-hmm. Very, very soft. You can actually cut it with a coin. Like you can
It also floats in water.
It does. It is one of the weird ones that is lighter, less dense than water. Yeah, so it's really interesting because most metals, when you put them in water, will sink because they are more dense.
Right.
It's just such an interesting... It is a really odd metal, basically, from all the other ones.
And it also, like, it can ignite in water, can't it?
That's the coolest thing. If you put enough sodium in water, it can go... go...
Was the sound.
But you know why?
No.
Why?
I don't know why.
So basically, sodium is a positive charge, and it basically breaks down the water. So the sodium and the hydroxide, the OH from water, combines. There's hydrogen left, and if there's enough energy in the reaction for sodium and hydroxide coming together, it ignites the hydrogen.
Whoa.
Which was the problem. Wasn't the problem with the Hindenburg. Because it wasn't the hydrogen that was the problem, it was the outside flammable material that occurred. So basically the hydrogen gas that's being given off in that reaction is what makes the explosion happen. Which is kind of cool.
So, another don't.
Don't put
a whole ton of sodium in water. Now, that's not salt.
Salt water is fine.
The whole ocean would be exploding if that was the case. But no, sodium.
Exactly.
By itself.
And
which is not...
You're not going to find it. Because basically sodium, and as we'll talk about with chlorine, they are so reactive that they are not found by themselves in nature.
They love to bond with other
They
things.
just want... They're serial monogamous.
They are lonely, lonely elements that just...
They just need to have somebody else.
I'd say like sodium and chlorine are like... They're like penguins.
Oh,
you know, like
they mate with something.
They just like bond together and they mate for like. I'm sorry, if that was really loud. That kind of cupped that sound.
But they don't mate for life necessarily because they'll switch partners.
Oh, that's true.
But they have to be with somebody.
Yeah. They
So
don't like to. They are serious.
He's so monogamous. I'll be with you forever. No, I'll be with you forever.
I can't be alone. I can't be with myself.
Just like it. And so, speaking of seawater, you were talking about that, right?
Yes,
That's what seawater, the majority of seawater is made out of, is sodium chloride. Mm-hmm. If you dried all the salt in seawater, it would cover all the land on Earth to a depth of 500 feet.
Wow.
It's a lot of salt.
I'm feeling parched.
Ooh.
That's a lot of salt.
It's a lot of salt, I'm just saying.
And yet, when we get into salt, you'll see how it was such like an important part of our... history and financially an important part of our society as well, which is funny because you feel like it's everywhere, but it's not. We'll talk.
Yeah, we'll talk about it later. So there's a lot of organic compounds that's used to make a lot of organic compounds. You actually modify alloys with it to improve their properties and fluidity. Smooth metals, the vapor lamps in streetlights, that's sodium.
The orange glow is what makes the sodium.
Because if it burns in air with a brilliant yellow flame. So that's one thing where actually if you take certain metals, and you can put them in flames, what color they give off is how you can tell what metal it is.
Aha! Yes, I think I had a lab a long time ago. Back when I was in...
Back in the day when I was in school.
In high school, and we did... I don't know. I just remember my favorite lab was when he put like a gummy bear in some type of flame and it screamed. I don't know what it was, but I just remember screaming.
It's terrifying.
And I was like, this is amazing. But I don't remember what it is. I obviously was an excellent student because I remembered nothing.
Awesome.
They also, they starting to use sodium because it reacts so well in solar farms as well.
Oh.
As a liquid molten salt.
Oh, yeah.
And they're using it in there's in Arizona there is a
There's an Arizona.
There is an Arizona. And in that Arizona is a solar farm that they're using molten salt, and the sodium is what's kind of creating continuous energy for the solar farms.
Interesting.
And store the energy as well. So I also saw that sodium is used in soaps as lye, glazes, porcelain enamel.
Well, this is salt, not sodium.
Well, yeah. But it sodium mixed with
so many different things.
Any gas really can make that porcelain enamel. It doesn't have to be chlorine.
True.
So
it's a feedstock for the chemical industry too. So sodium, they use sodium a lot into making a lot of industrial compounds.
Oh, it's also in liquid form. It cools reactors in nuclear reactors.
That is true.
So it's used as a heat exchanger.
Mm-hmm. I found that too.
Yeah, yes. I also found that it's in certain rocks in nature, which means it's combined with other chemicals and other elements. But if you know halite, or known as rock salt. Marasite, albite, and tourmaline, and labradorite, which is a beautiful...
As a dog?
It is a dog. It's probably also found somewhere in Canada. Mm-hmm. It is a beautiful blue color. I just think it's absolutely...
It is pretty, very pretty.
Yes, it says, this beautiful mineral is abundant in Earth's crust.
It is 2.4% of the weight of the Earth's crust.
Yes, and the labradorite is actually formed with high temperature molten rock, and so they are calcium and sodium rich. As the rock cools, the sodium becomes concentrated, and there can be anything from 30 to 50% sodium in a sample. So that is a whole lot of sodium in a pretty blue rock made from lava. Molten rock.
Yeah, sodium is obtained commercially by the electrolysis of molten salt.
Huh.
Yeah. So molten salt has got a lot of uses.
They're really into this molten salt thing going around. It's pretty exciting.
Yeah, I also have that in there. It's found in salt beds. Okay, so that's where a lot of our sodium comes from, is the giant salt beds that came from when there were oceans or seas, and they dried up, and you're left with the salt.
Right.
So, and those are really pretty to see if you've ever been to salt flats anywhere. But they're also found in minerals like cryolite, zeolite, and sodalite.
Ooh, sodalite.
Different names.
Soda.
And since but basically it's been, again, known since prehistoric times, but they didn't know it was the sodium itself, right? They know salt and
it's
sodium
different
carbonate.
Than the last couple episodes we've had, where the actual element was found in nature
by itself.
And we're going to be getting more into ones that are combined, and you actually have someone that discovered these elements. While they are found in nature, we're going to get into elements that someone had to go, hey, wait a minute. There's something else here.
Hold on. Actually, there's a funny thing about chlorine with that, too. But yeah, salt, of course, is one of the basic... That's how you make food good. You add some salt, make food good. All right, you saw flavoring, preservative. So I mean, that's how they survived for.
We'll be getting into using salt as a preservative when we go into the history of salt as well.
And they use sodium carbonate, sodium with carbon and oxygen in glass manufacturing that they would get from the Natron Valley in Egypt or from the ash of certain plants. Yeah, and it's weird.
Well, the carbon. No.
Yeah. Well, yeah. And one of the most important parts about sodium, and we'll talk about with salt, I'm sure, is the importance in your body.
Yes.
So if do you ever get cramps when you're running?
Oh, me?
Never.
I am so perfectly, my diet is just so perfect. I never get a cramp.
Never.
That's a lie. Just a heads up.
So there's a reason why they tell you to drink Gatorade and things like that, even though you don't need all the sugar that's in Gatorade. But the electrolytes are true. You lose electrolytes, which are like sodium and chloride, and those where it actually helps regulate your the fluid in your cells, the fluid balance. The sodium potassium pump is basically what makes your muscles go. So without that right balance, you'll have issues.
It's needed to help transmit nerve signals.
Exactly.
And like you said, regulate water levels. We have 8.8 ounces of salt in our body on average.
Yeah.
And when you sweat and you feel kind of salty and nasty, that's the salt leaving your body. And that's why you have to
replenish it.
Yes, you do.
Now, an interesting thing about that is that we get most of the salt we need from food, but especially we Americans love to just add more salt.
Oh, we have way more salt than we need.
Oh, yeah. So we take in something like, I think this must be like milligrams. I forgot to put the units on it. But you take in like 6 of whatever units they're talking about, and then you only need 3. So we're you know.
It is not surprising that, especially Americans, are like, oh, what? We double the amount of salt intake we need?
Yeah.
We double the amount of caloric intake we need? Fat intake?
Totes fine.
Like 20 times the sugar we need?
That's exactly what we need. I'm just saying.
We're America. By golly, we need everything in abundance.
Exactly. We might get run out. You never know.
Home of the obese.
It's true.
I really do love America, by the way. I'm not trying to...
No, it is good. But we do have... Everybody has faults. We do have overindulge.
We
Here it is. We have 100 grams in our body, and we need to replace with food. We don't need to add extra. And the average person eats, say, 6 to 10 grams, and we only need 3.
Yeah.
Which is why if you have high blood pressure, that's a big issue, because basically what you're doing is you're making your blood thicker, and your heart is having to push the blood through your veins, and it's harder. And since you have higher blood pressure, because it's literally the pressure against your arteries.
Oh.
Yeah, from the blood.
So if you have high blood pressure, cut back on the salt.
Yeah, that would help. Hopefully.
I just hear someone being like, never! You can't take my salt away from me.
I would have my salt.
So, should we move on
I think we should
to
move to chlorine.
chlorine?
Yeah,
Okay.
So we have some time for salts and the awesomeness that it is.
It'll go quick.
Yeah.
I promise.
Yeah.
I won't. I could go very... You could spend a lot of time, but I will be swift.
Swift?
Yes.
Oh, I like that. All right. So chlorine's different. So again, it was discovered by Davy, the same guy. Humphrey Davy. It's a great name.
That is really a good name.
Yeah. So, but in 1774, Carl Wilhelm Scheele. Yes, he heated hydrogen chloride with the mineral pyrrolite, which is manganese oxide. So he got the gas off of it, and actually originally was mistaken for oxygen.
Oh, yeah.
Like, it's not.
That's not.
So not oxygen.
Don't
breathe in chlorine, please. But in 1807, Davy again figured out that it was an element by itself. But what's interesting is that it took another 10 years for some chemists to fully agree that it was a separate element.
You know, when you get into the history of chemistry, there's a lot of arguing that goes on for years and years. Like, there will be a chemist that discovers an element, and it'll take years for everyone to finally agree.
It's the same thing with the new species in biology.
I mean,
it's very...
That's true.
They want to make sure they're right.
Right.
And some are just... a little
very
ornery.
Hard-headed.
A little ornery.
I like ornery scientists that are like, no. So I just find that really interesting.
It is interesting.
You know, it would be so frustrating, especially back in like
1807, right?
When you like,
no, this is something
you
real.
have to handwrite all your findings, and then you have Tommy run it down the lane to the next person, and you're just like, okay, well, it'll get to someone sometime, and then 3 years later, you get a reply back saying like, no, we don't believe you.
Right.
Like,
my life's work.
My life. My life expectancy is only 37.
Not cool.
Oh, come on, guys.
Help me out. So
chlorine.
The chlorine, and the name chlorine comes from the Greek chloros, which means greenish yellow, because guess what color the gas is?
Greenish yellow.
Yes, it is. So it is a nonmetal, which is when we salts, so sodium chloride, and all other like metal and nonmetals together, they basically call salts.
Oh.
Yeah. So we just kind of usurp that term for
we lump it all
just salt,
there.
right?
It's interesting that they chose Greek instead of Latin.
Yeah, so that's another reason. Like, there's no rhyme or reason as to which.
Don't you love?
We're not gonna have the same naming scheme.
No, we're not gonna have a pattern or like a census of how it's done. Well, just wait till you get to Californium, Berkeleyum, and Einsteinium.
I wonder who those are named after.
Well, who and what?
And what? Yeah. And where? We just need a when and a why.
I'm sure.
And maybe how. That was a grammar joke. Okay. So it's a nonmetal, and it is a poisonous gas. It is a dense. It's actually heavier than air, so it'll actually sink. So
that was actually one of the really interesting stories in Periodic Tales, the book that we, this podcast is based kind of off of, is that there's this in World War I. It was used in a Belgian battlefield. They had agreed, and they had signed not a treaty, but there'd been a pact that they weren't going to use deadly chemical warfare in World War One.
Because it's so horrific. Like, you're going to die anyway, but oh my gosh, don't die like that.
Well, and the tricky thing with if you're using chemical warfare and you're using gases is like
it floats.
If the wind changes,
you just killed a whole village.
Your people and your soldiers. And so so I'm going to whip open Periodic Tales and grab a few names out of here. There's a German chemist named Fritz Haber. He would later extract gold from seawater.
Oh, yeah, that guy, but then realized, like, wow, it takes so much work to get the tiny amount of gold. It's not worth it.
Yeah. But, so this guy, eventually he wins a Nobel Prize for his work, but it's highly controversial because he was listed by the Allied powers as a war criminal for this battle. So he decided to use chlorine. The tear gas was allowed in the war because it wasn't considered. It's non-lethal. Yeah,
it hurts. It sucks.
It sucks, but it's non-lethal. And so they decided that. So he decided, well, golly, chlorine's I guess non-lethal. That's not true. And it's denser, and so he released it down onto this field. And because it's heavier than air, it went down into all the foxholes, and it just
obliterated.
It just ripped these people. I have a thing here that talks about it. So it was the Battle of Ypres, and if I say that wrong, please correct me. So they fired 150 tons of chlorine gas at French, Canadian, and Algerian troops. Because it's heavier than air, the gas filled foxholes and trenches, turning the water in the soldiers' lungs to hydrochloric acid.
Burning them from the inside out.
Yes, causing 1,000 deaths and many more casualties.
And the gas, it will burn your skin, and it irritates the mucous membranes in your body, which are everywhere. Oh, you can smell it in as little as 3.5 parts per million.
Wow.
And with 1,000 parts per million, you can, in 2 or 3 breaths, you're dead.
Jeez.
Yeah. And if you've ever seen any of the, they have videos sometimes from people, like, dying from these things, from it, and it is a horrific way to go.
Yes.
Hence why they were like, we're not going to do that. We have some kind of decency.
Right. I mean, the whole point was that, we don't want to use... we want to use non-lethal
mass destruction.
Right? I was gonna say non-lethal warfare. Wait, it's war.
No. Did he get the Nobel Prize taken away at one point?
Not that I know.
Okay, yeah, interesting.
It was highly controversial, but he got to keep it, which is just kind of.
It's weird.
Well, but he discovered a lot about it.
Well, and there is a lot. So yes, that is the bad part of chlorine, right? Chlorine can be very dangerous.
Yes.
But it kills bacteria. Like, it's in our drinking water.
Yes.
From many places.
It's in our swimming pools.
If you've ever had that, sometimes they put too much. My eyes burned a little one time after going to the swimming pool, and because I was on the swim team, and I got home and I'm like, my eyes hurt, and my mom called, and she was like, this should not. You should be able to have your eyes open underwater in a pool and not have them burn later. And so they had put a little bit too much chlorine in the pool that time. Right. And it wasn't cool.
They also used using chloroform as well.
Right, yeah. So chloroform, an anesthetic, that was one of the first, kind of anesthetics that people would use. Carbon tetrachloride is a dry cleaning solvent. But both chloroform and the dry cleaning solvent are both under strict control now because they can cause quite a bit of liver damage. Oh, not good for you. So, but one of the coolest things, so they make 20% of chlorine products that chlorine is used in is actually make PVC.
Yeah, I heard that too.
Isn't that cool?
Yeah.
I did not know that.
Explain what PVC is.
PVC, I wrote out exactly actually what the PVC stands for.
It is a lightweight strong. It's used in car...
Polyvinyl chloride.
Yes. It's used in car interiors, window frames, water pipes, and even for blood bags.
Oh,
It is very, very lightweight. It is strong.
Well, and that's why they do it to make cars and stuff lighter because it's not as heavy. And we have a lot of the piping in your under your sink and stuff like that. Maybe PVC pipes, or your fencing can be PVC piping. Yeah, it's very, very common.
You wanna know a place in nature that chlorine shows up?
Where is that?
In one of the poison dart frogs.
Oh, I read about that one. Yeah. Yeah. It's like crazy. He's like, some frogs have it in the skin. Oh, I don't have the name of it.
I'm going to try.
I might be able to do that because I'm a biologist.
You are a biologist.
But, that's a good one. Epipidobates. So Epipidobates tricolor.
It has a chlorine compound in the skin that acts as a very strong painkiller. The structure of the compound closely resembles nicotine.
Oh.
A natural compound with pain relief properties.
In large doses can be fatal to humans.
Well, of course, it's a poison dart frog. People, don't go find this poison dart frog and use it as a painkiller medication.
Just saying.
Because it's a poison dart frog.
Poison.
Take that name.
Let's see. So, what's really kind of interesting, and I've known this as I'm a diabetic, so I looked at my drugs that I'm taking, right, my insulin, and I'm like, oh, it's got hydrochloric acid. Wait, what? It's got what? Chlorine? What? So 85% of pharmaceuticals use chlorine or its compounds at some stage in their manufacture.
Oh.
Yeah. So almost everybody's probably taken something with chlorine in it. For different ways, and a lot of pharmaceuticals, it takes a couple reactions to make the end product, and so a lot of liquid medicines will have it in a base of HCl. Pretty cool.
I was gonna say one more thing. If I can find it. Our bodies need chlorine to help us digest food, move our muscles, and like you're saying, to fight off germs. Yep.
And the hydrochloric acid in your stomach, that's chlorine. Helps it.
Right.
That's digestion.
Hydrochloric acid.
Right. But you remember that the reason why it doesn't eat through your stomach is because you got mucus on the inside to keep the acid in, and because otherwise it would eat through your stomach. Because it's like a pH of 2, which really acidic.
It really interesting thing that piggybacks on that. I was watching Naked and Afraid the other day. And this guy was doing pretty good. He was going along. He found this unripened fruit that had tannins in it. And if you eat too much of this tannins, it started to eat away the lining of his stomach. Like, it was so acidic. And this fruit creates this so that it's not eaten yet.
Oh, right. Defense mechanism.
It is a defense mechanism. And here was this guy who was he called himself the Los Angeles version of Tarzan. He ate out of dumpsters. He claimed he had the stomach of a vulture. And yet he's eating this unripened fruit. He's like, oh, it's really bitter. I'm going to keep eating it. Because, it's day 17 and you're out in the middle of nowhere and you're starving. But he actually had to be pulled out because his stomach lining was dissolving.
Well, you're basically creating a giant ulcer in your stomach.
Yeah. So, I don't know. You said stomach lining, and I thought of that episode.
Interesting.
So there in culture is not chlorine, but acid. It's interesting that sodium is a base and chlorine is an acid, correct?
Well, no. So chlorine isn't one or the other.
It's not one or the other.
No, it's
it
well,
has
I mean,
like hydrogen to make it a hydrochloric acid.
Right, because acids have hydrogen in it. Basically, they are hydrogen donors.
And the other ones have OH.
OH. Generally, there are some ones that can be hydrogen that can. It's a little complicated. You basically have to donate hydrogens. You're an acid. If you can accept a hydrogen, you're a base. Which most of the time means you have an OH.
And that's why water is neutral.
Right, and that's why you take acid plus a base gives you salt plus water.
Okay.
So if you took hydrochloric acid and sodium hydroxide, put them together, you get salt, water. Yeah.
Okay.
That is a double replacement reaction.
Whoosh.
Chemistry.
That's the sound of knowledge going over my head.
Whoopoo! Let's see. So in nature, again, chlorine is not found alone, only in compounds, because same thing as sodium. They're just super reactive. Most of it's found in those salt beds, just like sodium is. But you find it in minerals like carnallite, which is magnesium and potassium and chloride, and sylvite, which is potassium chloride. And most is taken out. You get our chlorine by electrolysis of brine, which is salt water.
And we'll talk about brine a little bit with the history of salt.
Cool. Yeah, you You get chloride gas and sodium hydroxide, and then you can electrolyze the sodium hydroxide and get the sodium out of it. It's very handy.
You have a whole backside?
I do. It's just, stuff we've already kind of talked about. Yeah. It's used a lot in industrial stuff: paper products, plastics, dyes, textiles, medicines, antiseptics, insecticides, solvents, paints. It's kind of a lot. Yeah. Hydrochloric acid is a really strong acid and a commercially very important one, like we talked about with the medications and things. Yeah, we talked about all that. It is. This was interesting. So it's part of the halogen gases, right? Right. So halogen means salt producer. Huh. And because they produce salts when combined with metal. Right. But that name was originally defined for chloride in 1811 by J.S.C. Schweyer, but then later applied to the rest of that group. Because in the periodic table, if you go down a group, that the columns have similar properties. Right. So chlorine, fluorine, all those have very similar things. And potassium chloride is a drug that prevents and treats low potassium. Magnesium chloride prevents and treats low magnesium. It's a way of getting those things into your body. Okay. And we already talked about the other things. It's also used as an oxidizing agent and a hydrogen substitution. And basically it makes other compounds have disinfectant and bleaching qualities. Oh. Yeah. Oh, odd one. You've probably eaten chloride because apparently carcasses from U.S. factory farms for chickens get drenched in chloride to rid fecal contamination. Gross. Yeah, I know.
I think I've heard that before.
Yeah, makes you want to go out and eat some chicken.
Mm-hmm. I think I've heard that from one of those terrible things, and you're like, I'll never eat chicken again.
And then you eat chicken. Like, it's totally fine. And mine's
organic. It's okay.
But that's the thing.
It was organic chlorine.
Right, because you just didn't use pesticides on it. Right. Oh, that's a whole nother story.
Know where your food comes from, people.
And one chlorine atom can destroy 100,000 ozone molecules. Wow. It is a bad one for
our atmosphere.
Yes, that's it. Mm-hmm. Yeah.
All right.
Oh,
well,
really quick.
I'm looking at
this is really cool.
But I'm just looking.
Chlorine, so there's a little bit of debate, like, should we have chlorine in our water or should we not? If it can be an increased cancer risk, but it's not classified as a carcinogen, so there's like some back and forth. But if you don't treat water, you'll get like E. coli and terrible bacteria that make you really sick. Or kill you. No. Exactly. And there are chlorine atoms that are found in these new novel antibiotic compounds that they find in tiny marine organisms near Norway. And the chloride, the chloride is essential to antibiotic activity, and it might be effective against MRSA, which is methicillin resistance staphylococcus or whatever the last one part of it is. But the antibiotic resistant, terribly bad bacteria. Oh, so interesting. So chlorine, although deadly, can save your life.
You know, it's really interesting. You know, Cindy and I were trying not to talk about this earlier when we saw each other because we want to talk about this and then we're trying to save it for you. But I love how you said you're like, well, there's sodium, which is, you know,
a soft lustrous metal.
A soft metal.
That explodes in water.
Mm-hmm. And then, you know, chlorine, noxious gas that can kill you. Together, delicious table salt.
It's the perfect example of how the elements, and when you put them in a compound, the compound has different properties than the ones before. Oh, they do. So, like, how those two come together to create delicious table salt is just fantastic. Mm-hmm. Mm-hmm.
Yeah. So, are you ready to learn
salt? I'm totally ready. Okay. I don't have any notes.
I'm pretty excited about this. Okay. I actually got a lot of this from an article in Time magazine. Oh. So, legit.
Time.
Too legit to quit. So, basically, let's go back to the very beginning. Mm-hmm. Animals wore paths to salt licks. Okay. Because they
you need the electrolytes. You need it. You're right.
So then men followed the animal paths. Right. Then they built roads. Oh. They built settlements.
It was all to the salt.
They literally have paths that went to salt. And so salt can be found in nature in a couple different ways. It could be mined. Mm-hmm. It could be produced by evaporation of seawater, like you said, those
salt flats.
Salt flats. And there's special ponds of brine, like in the mountains of Peru, where they're like sitting up in the mountains and they just slowly evaporate.
Yeah,
they just
chuck the
So roads were made
to get to salt.
to get to salt.
That's crazy.
And
it makes sense.
Because our diet switched to cereals and grains, we needed salt even more. And so we needed that supply. So as civilization grew, salt became the world's biggest one of the world's biggest trading commodities. Yeah. There were literal paths all across Asia to salt mines and salt flats. So a lot of Venetian wealth, you would think, oh, where does it come from? It comes from salt. It literally comes from salt. And back in the 6th century, salt could be traded ounce for ounce with gold.
Wow.
Yeah.
That's expensive salt.
I know, right?
Imagine trying to go to the store and I need some salt. That's $100.
We really take salt for granted these days. I'm like, oh, the
just salt. Whatever.
So Africa used cakes of salt as money, as currency.
Really?
Yes.
Money cake. How did they cake it together? Do you know?
That's an excellent question. Probably just like blocks of it, or just a little bit of water to keep it.
But the water would dissolve it right away.
You know what? I don't actually know.
Interesting.
But they did use cakes of salt.
Okay.
Roman Empire had a route called the Via Salaria, which translates to the salt route. There was a Roman road to the salt.
Get to the salt.
Tally-ho. And Roman soldiers were paid, part of their money was salt. And that gives us the word salary.
What?
Yes, sal. Salt comes from the word sal, that comes from the Roman salus, which was the Roman goddess of health.
Huh.
And then since they were paid partly in salt, we get the word salary. And if a Roman's wages were where did it go? Where did my note go?
Intermission.
Well, I had it somewhere and I can remember it well enough.
That was the Romans?
It was about Romans, because Roman soldiers, if they had their wages cut, they cut the salt, and that's where that phrase
cuts you to the
worth its wage in salt.
Worth its.
I had it. I feel so.
It's wages
in salt. Oh, where did that go? Anyways, there's a few phrases that come from the idea that they were paid in salt.
Wow.
Also,
you don't really think much about salt, and it was really
big deal. Do you know there's nearly 4 pages in the Oxford Dictionary that take up salts references?
Really?
Nearly 4 pages of salt.
Who knew?
Salt has a lot of religious meanings as well. Salt of the earth means the grace and wisdom of Christ.
Right.
In the Middle Ages, salt's sanctity, because it's considered kind of like a
purity,
rich in purity,
right.
It turned to superstition in the Middle Ages. Spilling salt became ominous.
That's right.
The pinch over the left shoulder, the reason why you put it over your left shoulder is that your left shoulders tend to hang out on the left side of your body. The evil spirits hang out
on the left side. The demon, the little devil.
The right hand is considered the dominant God hand.
Right.
And so the demons hang out on the left side. So that's why you toss some of the salt. You get rid of those demons that are coming at you because you spilled sanctified salt.
So, side story. My friend in Florida, her husband thought it was really funny because she had to do it. If salt was spilled, she would always have to do that. So he would purposely spill salt every single time we went out to the restaurant to make her do it. So annoying. But you're like throwing money away. Like, can you imagine doing that in front of somebody? Like, we had a time capsule, like going back to those days and just like, oh, whatever, pour salt here, toss it over there. They'd be like, oh my God.
I'd be like, that was
that's money.
Right. Thanks, jerk.
Thanks a lot.
Salt tax. There was a salt tax, and that helped ignite the French Revolution.
Whoa.
Yeah. So, because the the very rich people in France before the French Revolution, they had it's kind of like how we had in the United States, we had the Boston Tea,
Boston Tea Party.
Yeah, and how we had tea tax, and it was so
like,
high.
That's it. No, I can't do it anymore.
That was
the tipping point
with salt. They were like, we need salt.
Right.
They're taxing us to death on
salt. Right.
There was because the French government or the people in power had control over the salt and had control over it, so they could tax it as much as they wanted. Now, that's not the reason for the French Revolution.
Right, but it helped. Right. Well, it's just add one more thing, that the straw to the camel's back.
Was not worth his salt. That's
he was not worth his salt, right.
It derives from a soldier having his wages cut.
Oh, he's not worth that much salt, so we're going to pick... Oh.
I found it.
I love it when you find those things where it's used, these phrases we use all the time, and it's like, where did that come from? Right.
And a lot of times idioms really have no rhyme or reason, but then if you really look back at them, sometimes, I don't know if rains, cats, and dogs actually comes from it. That is an idiom that I taught in my second grade class, but worth his salt is.
Actually does.
In Christian culture, there's a lot for salt, and Lot's wife is turned into a pillar of salt.
Pillar of salt, right.
Because she did not have faith in God that they will be delivered from Sodom and Gomorrah. Which I always wondered, why was she turned into a pure...
it's a symbol of more purity, really, then, yeah. Well, because it's an antiseptic, it's, like chlorine and everything,
Egyptians also use salt to preserve
the bodies, Well, it's a really great preservative. Well, again, that's how everybody survived with meat for so long. You preserve your meat.
Like, okay, winter's coming.
Dry all the meat.
Dry out all the meat and preserve it with salt.
Jerky for days.
Oh, fish jerky. Put it in my belly.
Belly right now.
I have a funny story that has to do with salt and religion. So, when I was a wee lassie and I was in the leadership of my church.
They let you lead the church?
My youth group leadership
program. Oh, okay.
We were called SALT. And it came from the salt of the earth.
Okay.
We are the
salt
of the earth.
Okay.
Which is funny because the high school, I was in middle school, the high school's group was called Slugs.
Okay.
Because it stood for servant, leader,
right.
to God or whatever. So,
still,
I was like,
fun.
how ironic, but no one saw that.
The slug.
Yeah.
The middle schoolers are just gonna dry up the slugs.
Take out the high schoolers. But then, so we had these shirts made, and they said NaCl on them because we were salt.
Right.
And on the bottom, they had turned it into an acronym that said "Not a Common Love." NaCl.
Yeah.
But no one understood. They're like, knackle? What? Why does your shirt say knackle? And I'm like, it's a chemical compound for salt. And they're like, so you're wearing a shirt about salt? I'm like, actually, it's religious. And they're like, I don't get it. And I'm like,
that's a couple.
It was the person who did it was too diluted.
It
was clever.
It was clever if you knew the parts that went to it.
Yeah,
and if you
basically
didn't,
would have to put salt. Leadership, and on the back it could say NaCl or something. But
you'd have to have more connections.
Yeah, it was I think I still have that shirt somewhere waiting to be turned into a quilt because I saved all these t-shirts.
That would be really cool.
But so salt has.
It's hugely important.
It is, and you don't really think about it today as being. Important.
Well, and I think again, a lot of times you think here salt is it's always hypertension, right? You have high blood pressure, less salt, don't have enough salt, negative. But salt is essential to your body. If you do not have sodium and chloride in the right proportions, you will get sick. Mm-hmm. The fluids, the nervous system, all rely on those basic elements. Yes. And so it's okay to have salt, guys. Just don't pour it on your stuff. And again, we get a lot of it in the food that's there already. You don't need to add salt to it. That's really the problem.
Salt.
Right.
Yeah, that's where our problem is.
Yeah.
One more thing about pure salt.
Pure salt?
Pure salt. So,
the pink
have you ever
salt?
heard? Yes. Himalayan pink salt. It's much sought after because people believe that it is the purest salt on Earth. Although there's no proof of this. It is a rock salt mine in the Punjab region of Pakistan. It's made up of more than 95% sodium chloride. And it has larger crystals than table salt.
Right.
So, it is a very pure form of sodium chloride. Is it the purest? I don't know. It's delicious. I have a jar of it in my house, and I like to sprinkle it on things, and then it's pink, and I'm like, oh.
It's pretty.
I wonder why it's
But
pink.
that's one. I don't know. There's whatever the other 5% is. There's
Yeah, the
something in
5%
there that has
like
got rosy
rosy
qualities to it.
Quarty.
But yeah, that's one of those where it's become like somebody came up with like, ooh, that's really pure. That's gonna be great for you. It cures all these things, or it's really awesome, and it's really a little overblown as to really the benefits of it. Besides, and one really important part is that usually, when you get in the store, you buy iodized salt. Because we need iodine in our bodies and we don't have enough of it. That's why it's put in the sodium chloride in salt. You have iodized salt to get that essential iodized.
I thought it was like, I don't know what I thought. I was like ionized.
It's iodine. Well, they're already ions, so you don't do that.
I'm actually allergic to high dosages of iodine.
No, well, I mean, it's low. I mean, because the iodine, it's a trace thing. Like, we don't need a ton of iodine.
Right.
But it is essential enough. A lot of minerals and vitamins and things like that are actually cofactors in reactions and enzymatic reactions in your body. So, like, if you don't have it, that reaction can't occur. And so then you end up having, some kind of disease or issue because that reaction's not happening when it needs to. So that's great. As long as you're getting enough iodine in your diet, you don't need to have the iodized salt. But it was a way for everybody to get enough that they need.
It's kind of like how we're just like throwing like vitamin D and things.
Right. Yeah. Because you just don't have enough. You needed it. Right. So
another little cultural thing: the newest Star Wars that came out.
Mm-hmm.
That red planet. Mm-hmm. That's a salt. It's salt.
Oh, the red.
And, yeah. Well, the white over the.
Oh, over the red.
Over the red.
Oh, interesting.
And that's actually a place in Belize.
Oh, where they filmed
where
it?
They filmed it.
Ooh.
My dad was sitting there going, "That's Belize."
Like, no, Dad, it's a planet.
I'm like, no, Daddy. No, that's not how it works.
That's not. Just tell me that after the movie. Once we're finished.
Actually, he was sitting there, and I could tell he was like kind of going, okay, where is that? And then when it showed the places it filmed, he was like, Belize.
I was right.
Or not Belize. Maybe somewhere else.
Don't listen to her.
Dang it.
It's somewhere on this planet.
Oh. It's in Central or South America because my dad spent a lot of time there. She's going to look it up. And then he was able to tell the people around us, and I was like, my dad is so smart. He's the most smartest.
Oh, that's just telling us what it's called. Oh, the amazing earth science behind it. Maybe they'll tell us. Ooh. Oh, that one. Yeah, and they had the red coming out.
Where
That's
the
cool.
final kind of battle is, and when they dragged into the white planet and red would kick up, like that in itself isn't.
At the Salar de Uyuni, the largest salt pan on Earth, stretching nearly 4,000 square miles across the Bolivian.
Oh, I knew it was a B.
Bolivian, you were close.
Belize,
of the high
Bolivia.
Andes. The
Yes,
Bolivian
yes.
Altiplano of the high Andes.
Yeah, so my dad had been to those, so he was like, he knew where that was.
Oh, and it doesn't have color changing sand. Apparently, that's a thing. But yeah, anyway.
Well, no, they added that.
Right, yeah, but the
obviously,
salt
for the
flats
effect.
were
But
there,
the salt
right?
flats are in Bolivia. I said Belize.
Wow. But we don't have. Nobody has to come in and check us because of the internet.
Oh,
That's
isn't
good.
that great? You don't have to correct us now.
Well, there may be other things,
You
but there's not on that.
at least to correct us on Bolivia.
Well, we're almost an hour now, so I think.
Wow, we really took our time with this one. We started this episode going, this isn't going to take us very long. There's not that much to talk about. Well, what's great is that so much of our, what we talk about is connected to things in our life and things in nature and other chemistry.
Other chemicals, yeah. It's all connected.
I know.
Chemistry's cool. That's why I keep telling my students all the time. Sometimes they believe me.
Yeah, I don't know. You still have to convince me it's cool.
Oh, right. Dang. All right. Well, we'll continue to
I
try.
just really wanted a podcast.
Don't let her say that. She really likes this stuff.
I really do. It's really fascinating, guys. So, anyways, if you have any questions, comments, concerns, please feel free to email us. Our next episode. Well, that might be a lot for one
might be a lot.
episode.
We're gonna do probably some other metals. Let's just go there.
Yeah, we're gonna do
some other metals.
I wanted to call this episode "Get Salty with Me," but we'll see if that sticks.
Puns. Maybe we find some even better pun.
I made that up months ago when I was trying to create different chemicals together for this episode. So if you can think of something better, by all means.
I probably can't.
Oh, well,
All right,
we'll see. But thank you guys so much for listening. We hope you enjoyed. Please feel free to send us an email if you have any questions, comments, concerns. Be sure to subscribe, and you'll be able to hear us next time.
Next time. See you later.
Bye.
Bye.
Hello. We're kissing hike. That feels a little weird. My cheek is resting against Cindy's.